All right. Hello and good morning, everyone. I hope everyone's had a fantastic week so far and is ready for a great presentation to round us out this week. My name is Damien. I work with our manufacturer partners, and I will be in the background moderating this week's webinar and this year's first guest webinar. This topic in particular, I think, has come at the right time off the heels of our major lighting module update late last year, which you may or may not have had a chance to play with yet. If you are either a seasoned lighting designer looking for a refresher or just starting to get into lighting design, this will be great for you. Today we have Brian here from Unique Lighting, one of LandFX's manufacturer partners, and I've been working with Brian since early 2018. It feels like a lot longer in a good way, but shortly thereafter got working more specifically on the aspects, on some aspects of the updated lighting module since mid 2018. So just quickly, I want to make sure credit is given where it's due and thank him as well as all of our other lighting manufacturer partners and LandFX users who have actually given us feedback and input on the development of this module so far. Having said all of that, Brian is going to go over, as this webinar title says, landscape lighting codes, guidelines, and techniques to implementing an effective and efficient lighting design. And before I do hand over the mic to him, I just want to be a little proactive in answering some potential questions that may come up right now, which is this webinar specifically will not go into the LandFX lighting module itself, but don't worry, we do tentatively have a scheduled date for more on the actual lighting module to be explored and explained for about the end of February. So please keep your eyes out for that, in the newsletters and any other announcement platforms. If you're really interested in that, these two presentations will go really well hand in hand. And before we get stuck into today's presentation, let's quickly go over our usual housekeeping items. If you have any questions throughout the webinar, please type them into the Q&A window, not the chat window, the Q&A window, which can be accessed by clicking on the Q&A button on your screens. Some questions may be answered by me directly. Otherwise, we'll have a moment, maybe two, to answer the questions during the presentation, for which I will ask them directly to Brian, and he can respond that way. So from here, I'll just hand over to Brian to introduce himself and get us underway. Thanks, Brian.
Thank you. Can you hear me, Damien?
I can, yes.
Okay, perfect. Well, thank you, everybody. We've got a lot to cover today, so I'm just going to jump right into it and just get rolling. So first off, this is me. I'm Brian Qualls. I'm the National Business Development Manager for Unique Lighting Systems. Prior to that, I spent most of my early career as a landscape architect. So I've worked in many different types of offices, from little boutique firms all the way up to big nationwide firms, and back in 2011 got lured over to the dark side of manufacturing and has been here ever since. So what's nice about it, and the reason why I bring this up in my trainings, is that I do look at things at a little bit different eye, similar to what everyone on this call, how they look at things from more of a design side. Like I said, I've been on that side of the table. So if there's ever any questions on lighting or just design in general, and we don't cover it here, feel free to reach out to me. I'd be happy to talk to you as we go through. Real quick, here's kind of the agenda. The title itself is our agenda, so we're going to kind of run through a little bit of codes. I'm not going to promise you that at the end of this you're going to be an expert in everything, but it's going to hopefully kind of clear some of the fog that's out there, especially using the new module for LandFX, of kind of where do I start, how do we get going, am I doing everything that's going to be kosher with plants. So I don't know about you guys, but I'm super excited to talk about codes. So let's just go ahead and jump right into it. Now, for low voltage lighting, there really isn't a lot out there. I wish I could just point you to one location and say, this is it. This is going to cover everything you're going to need, and it's not. So majority of the stuff that covers us is the National Electric Code. So a lot of people, will call this low voltage lighting, but at the end of the day, it's still electricity. So the National Electric Code just came out with their latest edition, the 2020 edition. Um, I am not suggesting, or nor do I recommend you run out today and go buy yourself a copy. It's quite expensive. It's I think I paid $120 something for mine. It's 900 pages, and there's very, very little that actually is specific to low voltage lighting. You've got to sift through it and find the different codes. So for your benefit, I've done that, and we're going to go over a lot of it today. There are several municipalities out there that do have local codes, and of course, just like anything else that we do in design, the local codes will supersede the NEC, but the NEC is there if there's nothing that exists. And my experience has been there are very, very few municipalities that have local codes pertaining to low voltage. And if they do, they probably haven't been updated in a while, and it gets a little tough. One of the things that I've run into quite a bit is if you're submitting plans, and this is kind of a cautionary tale, if you are submitting low voltage lighting plans with your set, sometimes they'll get caught in limbo and you may have to intervene. And what I mean by that is the landscape reviewers don't want to review it because it's electrical, and the electrical reviewers don't want to review it because it's low voltage. So be aware of that. And there's times in the past where I've just had to make some phone calls and kind of walk people through. It's very few and far between, but it does happen. And then the last two things on here is dark sky ordinances or night sky ordinances. We'll talk about that a little bit more. Again, there's really not one size that fits all. And then we've got product listings for each of the projects, which you've probably seen: UL, ETL, or TUV. With that, let's just go ahead and jump into some of the National Electric Code highlights. So the first thing, NEC defines low voltage lighting as systems that do not exceed 30 volts. So what'll happen is a lot of manufacturers out there are making transformers that don't exceed 15 volts, and sometimes that gets kind of questioned into why others are higher than that. So if you're using a transformer that has a secondary tap that's above the 15 volts because of voltage drop or distances, you're not breaking the National Electric Code. We can't make transformers that are going to break the National Electric Code, so you're okay there. And the wire can be direct buried, as long as it's rated for direct bury. It does not need to be in conduit, and unless there's a specific reason, I highly recommend that you don't put this wire in conduit, especially UF rated. It's very hard to pull, and again, why add that expense to your project if you don't need it? And wire only needs to be 6 inches deep, a little bit deeper under sidewalks and driveways, but it makes it real easy. Put it in there. A lot of people ask me if they can drop the wire in the same trenches as the irrigation. I tend to recommend against that. I know it makes it easier, but at the end of the day, it's still electricity. So electricity and water don't necessarily mix. I kind of like to separate those as much as I can. And then as the last kind of bullet here, NEC talks about the max amplitude on wires, which we're going to talk about. And the big thing here is your trunk lines. So the big lines that are coming out of the bottom of the transformer, cannot have a smaller rating than the transformer unless that wire is fused. So we'll talk about that. Here's a quick snapshot of what the manufacturer amp ratings are for wire. So if you were to look up, Page Wire or something out there, this is what you're going to get. But we have to have some safety regulations put in to kind of, you don't want to run everything at 100%. So you certainly don't want to put 30 amps on a 10 gauge wire, and the NEC kind of works down, and you can see how much we have to, pull the wire down from what the manufacturer says. Now, if you look at it, it looks like wow, that's a pretty big jump. I've got a 25 amp wire, and you're Brian Qualls, you're telling me I can only use 16 amps on a 12 gauge wire. That seems excessive. And where we get that is, I live in Phoenix, Arizona, so I have to kind of err on the side of caution. And there is a ambient temperature correction factor that goes within it. So for me, when I'm talking to most people, I'm setting myself for that, 100 degrees Fahrenheit. So that 100 degrees Fahrenheit is giving me a correction factor of 0.82, and then what we call a D rating, we reduce everything by 20%. So that D rating takes me down to that 16 amp range. If you're in cooler territories and you're never going to hit that 100-degree range, trust me, I can tell you there's times when it's still 100 degrees at 10 o'clock night here in Arizona. But if you're not in there, then you can give yourself a little bit more wiggle room on the amps. Now, again, I don't expect you guys to memorize this or go through it. If you're at that general 20% D rating off of the manufacturer's recommendations, you're going to get pretty close. And then the trunk line, I mentioned this before. This is probably more important than anything else. And so what happens is majority of transformers that are out there will have a transformer breaker built inside. So if there's any type of a short, or if there's any type of overamping situation, that transformer itself will automatically shut down. But it has to exceed that 25 amp rating. So let's say, for instance, I've got my system set up here, and I've got my 25 amp max rated transformer, and I'm putting that 16 amp wire that's on there. If I have a short or something that happens, this wire here is actually going to burn up before it ever gets to the 25 amps on the transformer. Now, I've been a field guy for several years, and I've gotten those calls. Well, why did my wire, burn up and the transformer not trip? It should have known. And it says, well, the trip or the wire couldn't handle that that amp rating before that trip. So the way to get around that, so that way you're meeting your NEC code, is to put a fuse in between the wire and then wherever your first run of lights are. Ideally, you want to have that fuse sized to at least match the amp rating on the wire. But one of the recommendations that I do is that I have this fuse here match whatever the load is out in the field. So if I've only have 8 amps of load on the transformer or on that wire, then I'll put a 9 or 10 amp fuse on that. It's a lot to think about. It's a lot to remember. Usually you can cover it with a note in your general notes rather than trying to go through all your plans and figuring out what size to put on there. You can, but if you put a note that, hey, there should be a fuse coming out of the transformer and that fuse should be sized per the load, that would cover you, and contractors should be able to follow that as you go through. Moving down the scale, as we get down to the local codes, again, I wish I could just read off a list and give you some highlights, but everything is different everywhere you go. There's, like I said, oftentimes they're very vague, they're not up to date, and really, if you follow through kind of more of the NEC type stuff, you should be covered as it goes through. Really, again, and go through it. If you ever get stuck, or if you're looking at something, feel free to reach out. I'd be happy to kind of help you walk through it and see where it goes through. But there's very few municipalities that I've run into that actually have a low voltage lighting code. And then product listings. So per the National Electric Code, every product that's out there needs to be listed. There are 3 listing agencies, and I've had 3 of them listed there: TUV, ETL, and UL. Probably the most popular right now is UL listing. So basically everything in your house that you plug into the wall will have one of these listings, from your toaster, your ceiling fan, and quite honestly, everything that you're specifying out in the field should have that listing. It's going to be very rare for you to run across a manufacturer that isn't listed. If you're have some contractor that says, "Oh no, I make my own in my backyard or in my garage, and please use those." The chances are those guys aren't listed, but every manufacturer certainly out there is going to be listed. And basically, these are third-party testing agencies, and they're testing for safety. We're going through a process right now at Unique Lighting of updating some of our transformers because the testing has changed, some of the requirements have changed, which has caused us to go back on our larger transformers and make some updates. So we'll be launching some new transformers here this spring that are continue to follow through the required third-party testing. And then my favorite, dark sky, night sky ordinances. If you're looking at all the codes, this one is going to have the most variations, and this one's going to be probably the most strict that's out there. The hard part with dark sky ordinances is that they can be anywhere. I've run into them through actual government municipalities. I've often had to go through HOAs that have had their own, and I would say that I have met some of the most difficult HOA dark sky ordinances that are out there. The main part of having a dark sky is, of course, right, we want to make sure and preserve the skies. We want to make sure we can see stars and the night sky at night, and light pollution is a real thing, and we want to make sure that we do it. So ideally, what happens is you want to look at fixtures that have a zero cutoff, and what we're trying to prevent is just light shooting and basically taking a light and shooting it straight into the air. You know, the Luxor at Las Vegas is a prime example that, you know, it does not follow the rules, and that's what we're trying to prevent. So my first advice to all of you that are listening is whatever you do not try and go head on with any of the dark sky ordinances out there, even if they're completely ridiculous, even if you feel that this was written by someone who doesn't know anything about lighting. I have yet to win a deal with any dark sky ordinance when I went head on with them. The best example, I got two examples I can give you. One, I was working with a homeowner at an HOA. Some reason he felt like he had pull with the HOA and kind of wanted to just ignore it, take it in there and say, hey, this is design, this is what I'm doing. And we basically went from a 20 light job in his backyard that was lighting walls, and we were very, very controlling the light, and through the HOA ended up with 11 path lights in his backyard. So we really had to compromise on our design, and it didn't go well. So I've even had other HOAs where I've proved that I followed their ordinance to a T, and then they came back and rewrote the ordinance and said zero up lights, everything has to be a down light. So my advice to you is, if there is one that seems restrictive, try and go in there and talk with them a little bit more, figure out what their motivation is. You know, generally what they're trying to prevent, and they can't explain, is they're trying to prevent glare. And if you go through and say there's many fixtures out there that have glare control shrouds, and we can aim the fixture so we're not shining it in the windows and things like that, that usually if you get in on the front end and talk to them, you can find a nice, good way to get a compromised design without getting it completely cut out. So I was talking about zero cutoff, and this is an example of what they mean by zero cutoff. So if you have a horizontal plane, no light can pass above that horizontal plane. You know, and this, you know, is to like carriage lights on the house or anything that, you know, draw that line, no light can go through it. And as an example, even though this is a path light and it is shining down, this would not pass most dark sky ordinances, even at that little angle, because you are now above that horizontal line. The other thing that this would not pass is because it has the adjustable knuckle, so that you could even go out there and say, I'm going to adjust this, set this up, great, and then later, because you can adjust it out, it's not a fixed, it wouldn't pass. Now, I will say with everything that we're talking about, even the NEC, the local ordinances and dark sky ordinances, there are no police out there. There is no NEC police. You're not having to submit any plans to the National Electric Code. There's no one to review that section. If they're going to get reviewed, they're going to be reviewed by each individual municipality or HOA, kind of more as a design review, but very few go out there and actually go out there and check with a light meter and making sure you're doing this. Now, I'm not suggesting that anyone go out there and try and do a end around and do that, but you know, it's just know that there really are no light police out there. You know, again, depending on where you're at. So I borrowed a couple of these pictures here from Moab off their website, which is, you know, kind of gives you an example of what they're trying to do. And the picture on the right kind of shows you what they're controlling. And really idea the best there really puts some handcuffs on us when it comes to lighting. And in my opinion, it's a little bit on the overkill, but I would, you know, never want to do the very bad. I want to light with purpose. I want to put a light to make sure that it's lighting a tree or I'm lighting a sign. I don't want to just put a light out there and try and blind the neighborhood or, you know, floodlight a whole area. I really want to do is light with purpose. So Damien, do we want to stop here? And
yeah. We do have a few questions, and they are all from Jeffrey. He's had some really good questions so far. Starts out as a bit more of a comment, but he prefers conduit to direct burial, and asks, can you not just pull the THHN type insulated stranded wire instead of the UF cable? He says it offers more protection and is easier to make modifications to the system in the future.
Yeah, no, you can, and that if you are in a situation you're worried about shovel kicks from maintenance guys, or you do want some protection, that is certainly up to you in your design. You know, it's not needed if you're kind of more of an intimate space where you know, there's a garden and you know that I don't have a commercial setting and I got a maintenance crew that's out there every week. Yeah, just because you don't have to doesn't mean you can't. So if that is your preference, like I said, you want to add that protection, certainly please feel free to go ahead and put it in conduit.
Cool. So his second question was that in New Jersey, which I'm guessing is where he's based, and some other jurisdictions, they've been pushing to allow landscapers, not licensed electricians, to install and design low voltage lighting. As an architect in LA, I have mostly used line voltage lights. The electrical contractors are fighting it, but unqualified tradespeople or trades are pushing to work in areas for which they are not trained or licensed. So it's more of a discussion point, but he said, do you have any thoughts or opinions on that scenario or that process taking place?
Yeah, I do. That's a great point. We run into that, especially in the Pacific Northwest. There's a rule in the Pacific Northwest that a landscape, you know, if you're not a licensed electrician, you can't even hang a transformer above 60 watts if you're not licensed. And for the most part, most of the transformers out there that are 150 or 300 are they have a pigtail on them. It's just like plugging in your computer or plugging in a TV. So, you know, to have a licensed electrician come out and plug into a wall for me seems a little excessive. So again, that's something that does vary from municipality to municipality. Where I live, majority of the places I go to, a land, you don't have to be licensed to install low voltage lighting. My feeling is, and there's a reason why they're fighting it, Jeffrey, and the electricians are fighting it, is because it's potentially taking work away from them. I think that these systems, especially now that we're getting into LED, and a lot of manufacturers like Unique Lighting Systems, you know, puts on so many training courses throughout the year, that it is a safe system, that just about it, I shouldn't say just about anyone, a lot of people can install, if they're already a professional landscape contractor should have no problem installing a low voltage lighting system. And I'm a little biased because I work for the company, but I see it. Line voltage does have its constraints where we get a little bit more flexible on the low voltage, especially with LEDs. That again, I don't have to go as deep with conduit. I don't have to go as deep with wire, and my price point is a lot lower on the low voltage side than it is the line voltage, and so it gives me help saving budget, that I don't have to start putting in these smaller caliper trees or smaller shrubs. I can save that budget on lighting and put it back into my landscapes.
Awesome. Thanks for the detailed response. It's really
Sorry.
good. No, it's really good. So his last question was, and we do have one more after this, but Jeffrey's last question was in relation to the dark sky zero cutoff. That is direct light from the luminaire, and what about reflective surfaces? What's the, I guess
these are all great questions. That is a fantastic question, and again, it goes back to municipalities. So, one of the most strict ordinances I've come across is the city of Flagstaff, and they're at that point because there are some observatories, some telescopes up in the hills, up the mountains up there. They have gotten to the point to where they are dictating the color wavelength that comes out of the light. So if you go up to Flagstaff, if you've never been, it's a beautiful part of the country, but if you've been up there at night, it has a very orange feel to it. And that's because they're putting that wavelength color that comes out of the light, so that way it's not visible from the telescopes. And they are now rewriting their ordinance to start controlling the light that is bleeding out of windows from the buildings at night. That is on the extreme, and they're probably the only ones that I've run across that have done that. I'm not saying there aren't others, but for the most part, I don't see anyone that talks about reflectivity. They're more worried about the angle, the pointing of the light, where it's pointing. Probably one that I see that goes that I see repetitive all the time is they want to make sure that any light that you are placing is pointing away from any property lines. So the biggest concern for most of these municipalities is they don't want you designing a system that's going to shine light onto the neighbor's property. And that's kind of the more control than anything. And, and then again, if it's pointing up, or if it's just flooding light into the sky, that's a big no-no. But for the most part, I'm not running into too many reflectivity constraints on the lighting, on the dark sky ordinances.
Awesome. One last question for this little block from Michael. He said, have you heard of any restrictions regarding the mounting of transformers on a home? He says in the past he's mounted them on a 4x4 post as a safety precaution.
I have not heard any restrictions. I mean, I've had owners and project managers kind of express that they didn't want it on the side of the house, but part of the NEC, we have safeguards built in place that they can be. The only requirement that I'm aware of is that it's got to be mounted a minimum 12 inches off the ground, but you don't necessarily have to put it on a post. You can mount it. Now, again, the local codes may restrict that, but I haven't run across any that said you couldn't mount them on the side of a house.
All right, great. Yeah, we do still have questions, but I will leave them till a little bit later on. We'll keep kicking through this next portion of the presentation. So yeah, keep on going.
Okay, great. We're going to jump into now just kind of the guidelines of how to lay out a system, and wanted to just, these are generally the 4 questions that I get. How do I know what size transformer do I need? How many do I need? What's the longest run I can put, since it is low voltage, and then ideally what's the best place to locate the transformer. So let's talk about how to know what size transformer you need. So with a lot of, just about everyone I talk to who's new to lighting or who's kind of getting into lighting, is picture a transformer like a bucket of watts. So I've got a bucket of 300 watts here on the screen. And if I said to you, and I said, you know, Damien, I'll use an example. Hey, Damien, I have 3 water glasses I need to fill up. What size pitcher do I need? That's exactly what we're doing with transformers when you ask me that. So if I've got my 3 pitchers of water that I want to fill up with that, what size do I need? We basically just got to look at, well, what size are these pitchers of water? So if each of these are 50 watts, now granted, I'm using this to make the math easy. If you've got a 50-watt LED, you're gonna get in a lot of trouble with every dark sky ordinance. But anyway, if I've got 50 watts kind of pulling out of this, then I know that I've got plenty. I'm only using half that transformer. But back to NEC, the rule is, like we talked about on the wire, that we can only use 80% of the wire. Same thing goes with the transformers. You can only load a transformer to 80% of its capacity. So I certainly cannot use a full 300 watts. So really, my pitcher of water is only 240 watts. But as you can see, I'm still well under that. If I go to the next slide here, that if it was down to the 90 watts, which is the 80% that's left, I'm still have, or actually if I use the 150 watts, I still have 90 watts of reserve. That is killing me. That, you know, without that rule, I'd have 150, but now I still have 90. So I still have room to kind of be okay with sizing this transformer. It gets tough, and I know how it is, because as we go through, we don't always have the time. You've got your contractors, your project owner wants to know, you know, budget numbers, give me an estimate, and it gets kind of tough until you start really designing it. So a lot of times I use what I call the 80-20 rule. If I reduce my transformer by 80% and I go out there and I add up, and if I think, hey, I'm going to have, you know, 10 watt LEDs out in the field, I'm going to add 20% to those, and that'll make sure that, hey, okay, so instead of saying I've got 100 watts, I've actually got 120. That'll give me a good rule of thumb to, just before I start laying out wire, designing, and figuring out voltage drop, the 80-20 rule get you pretty darn close in the beginning, the early planning stages of your project. So real simple, add 20% to your total watts, reduce the transformer by 80%. That'll tell you what size transformer you generally need. And then, of course, as you roll through your project and you use the software through Land Effects and start designing it, then you can get more refined on what size transformer that you need. Now, for me, one of the things that I like to talk with designers when it comes to lighting is lighting's probably one of the toughest things to deal with as a designer and working with the end user, because once we're done, once that project's installed, we lose complete control. And you know, if you try and design this thing right to its razor's edge, and that homeowner or that project owner decides, hey, you know what, these 4 watts aren't bright enough, and runs down to Home Depot and buys 5 watts, well, he could start shorting out the transformer, he could start shorting out the wire. Or after the project's done and you've gone on your way, he goes out to his maintenance guy and says, hey, why don't you add 5 more lights over in this corner? Again, if you're running that at that razor's edge, you could start overloading transformers and wires. So I usually try and give myself a little bit of freeboard. I bump up to the next, sometimes I'll bump up to the next size transformer. There's a plethora of transformers out there. So if I'm at, you know, using a 150 and I'm pretty close, I may bump that up to a 200 or a 300 watt transformer. In general terms, you're paying about $1 a watt installed for a transformer. So in the whole grand scheme of things, going from a 150 watt to a 300 watt transformer, you're adding $150 to the project. So it's not a big, huge deal to kind of give yourself that peace of mind that your transformer and your wire is going to be sized correctly. The next question that we get is, what's the longest run I can have? And again, it all depends on how much load you're putting on that transformer or on that wire, and the size of that wire. So here I have on the screen, if we're using 12-2 wire and we know we want to keep that around 16 amps, the example I have here is that if I've got 40 watts, and for this, if I'm doing the math, you know, that's 4 or 10 4-watt LEDs, and let's say I've got them in a cluster 100 feet away from the transformer. That will drop 1 entire volt in 100 feet. Now, for the most part, LEDs that are out there, just about every manufacturer, their minimum operating voltage is around 10 volts. Ours is 10 volts. And so if you think about it, if you're in the 12 volt tap, I can drop 2 volts and still be okay. So generally, you want to keep your wire runs around the 200 foot level max with 12 2-wire. Now, all this changes if you use 10 gauge wire, of course, because 10 gauge wire is bigger, and you can go a little bit further, and we've done that. But I use this at the very beginning stages. I've got the contractor, the design build contractor, I've got the owner saying, I need to know how many transformers you're going to have on this job. I'll take a transformer, I'll put a 200 foot circle around it and kind of place it and make sure that they're close enough to each other that I'm not going to exceed 200 feet away from the transformer, and I'm hitting all my landscape areas where I want to go. Again, once you start refining your design through the land effects software there, you can then see if you can run further and make sure things do that. Kind of on the practical side of it, I don't like going above 200 because it gets tough to manage in the field. Again, like I said, you're paying about $1 a watt for a transformer. So having 250 watt transformers kind of strategically placed is roughly the same cost as one 300 watt transformer that's dead center, and you're running all this wire. And for those of you that are putting in conduit, that's a lot more conduit that you can tend to save on. So that's kind of where I'm at with the rules of thumb on the wire. So I've been talking about watts and amps, and I'm probably thinking I probably should have done a little bit of a definitions between the two as I'm thinking about it. So an amp is kind of basically it's your pressure. So how you figure out amps in a system is you just take your total watts divided by your volts. So if I've got my 40 watts, I divide it by the 12 volt on the system, that'll give me the amps to figure that out. Back in the days when we were doing halogen, that's all we needed to do. So a watt was a watt was a watt. Today, a watt is still a watt on LEDs, but now we're dealing with volt amps. And we've always dealt with volt amps in the past, but we've never talked about it. And basically, volt amp is the measure of the apparent power that LED is using. Back in the days with the halogen, watts and volt amps were equal. It was a power factor of 1. So if it was a 25 watt lamp, it was 25 volt amps. Now with LEDs, that is changing. And I've had 3 different electrical engineers explain it to me, and the best way that I can describe it is where you're looking at a watt. Watt is what we're paying our electric bill. That's how we get charged. The volt amp is what is actually being used through the wire and the transformer. So we need to size our wire, size our transformers based on volt amps. So it gets a little tricky at times. Just about every manufacturer, and here's a shot of one of our spec sheets, will identify their volt amps on their deal. So this is part of our 5 watt par 36, as you can see, actually uses 6.7 volt amps. And so I use that when I'm doing my sizes. And as you can see, if you're doing smaller systems, probably not that big of a deal. But when you start adding that up over time and you're doing 30, 40, 50 light systems, you could be off on a transformer as you go through. Now the 80-20 rule will still cover that, and I factored that in there. But again, look at the volt amps from the manufacturer. If it's not posted, difficult to find, if it's not on their website, then I usually just multiply the watts by 1.5. It covers you all the way through. It's not going to be exact. For us, some of ours LEDs only have a power factor of 1. Others have a little bit more than 1. So if you do the 1.5 volts, that should cover you when you're doing your final calcs as you go through. Okay, we're going to jump right into lighting techniques. These are very, very kind of general ideas of how to light landscapes. The first one everyone knows, everyone does. It's kind of uplighting. And the tough part with uplighting is that you kind of flatten out your what you're lighting. You put something on here, and I kind of show you a picture of I'm making, it's really easy to create a hot spot. You get real dark spots at the top. And there's several landscape architects I work with, you know, and they want me to review their plans. That's the first thing. It's like you see one tree, one light, one tree, one light. And again, I get it. I'm a working man. I know there's budgets out there, but if you can, I generally like to put 2 lights per tree. And we'll go through that in the next slide here. But on the screen, I've got a couple of examples of bullet lights or well lights that you can use for uplighting trees. There's pros and cons to both, and it depends on your situation. Out here in Arizona, I like to use a lot of well lights, and the pros for the well lights is that they're not visible during the day, and since they're buried in the ground, they're less susceptible of getting knocked out of alignment by maintenance workers, users of the space. Everything's contained inside that well, and it's pretty much stays locked on to its target while it's in the ground, where the bullet lights or the larger bullet lights, they get hit by line trimmers, people walking by with roller bags, and you know they're continuous, ready to having to be adjusted over time. Downside with a well light is there have been many times they get overgrown by ground covers, dirt, rocks, whatever you're using for your mulch, and they get kind of lost in the landscape if it's not well maintained. I had a project once where I got called and said this project just looks so dingy from the first day, and we can't believe it. And went out there and showed them the plans, and about 30% of their well lights were covered by ground cover, and they had to go back and trim them back. So pros and cons to both, but that's kind of some ideas of what to use as far as products. Cross lighting, this is what I mentioned, why I like to use 2 lights per tree. And as you can see here on the picture, all these palm trees here, this is a picture in Florida, has the 2 lights per tree. What's nice about this, as you look at it, what I'm doing is when I'm doing this cross lighting, I'm now giving this tree a lot of definition, to where what I call striping right down here in the middle. I'm getting a little bit of shade and shadow. It's giving it a little bit of a 3-dimensional look to it. It's not so flat, and I'm able to hit the tops of these trees without putting these big 50-watt lights in there. I can use smaller wattages and then still hit the tops of the trees. Now, some of you are looking at, well, Brian, you still have hot spots back here. And again, that's all viewpoints and how you're looking at different angles in the space. That's a discussion for another day, but generally it's you can control that. And sometimes this is just from where the camera is sitting. So backlighting, this is something that gets used probably not as much as I would like to see it, but it really adds a nice effect. If you need something a little bit more, kind of more of a romantic space, you don't really need to highlight the area, but you still want to have light in there. Now, we did this. The photo here, you see this was actually done by with a demonstration, and we did it quite by accident. If you can tell, I've got a hardscape edge. I couldn't put the lights in front, so I put them back and back, and as we turned it on and lit it, we ended up bringing this rock wall into our space. Had I front lit these trees, that would have been dark and probably wouldn't have seen it, and probably would have come back and added more lights along the back and tried to wall wash it, and that wouldn't have given it the same effect that we have now. So oftentimes kind of look beyond just what the tree you're lighting, see what kind of ambient light you're getting that can help bring in other features into your space. One of the big things I tell people is if you don't light it, you don't see it. So it's kind of a neat look. And again, these are some more examples of just the products to use. Downlighting, I don't get much into that here in Arizona. Our trees are installed pretty small, and nobody. I still have yet to find someone that's willing to climb a cactus for me. So, but when you do have big trees like this, you get a real nice effect here on the ground. So if you look in the picture, you can see where we've got these trees attached. There's several ways to attach a tree. Several of our fixtures have a special kind of bracket that we put in the tree, so that way as it grows, the tree won't girdle around the attachment. And then you use the longer shrouds to prevent that glare, so we can just see the light source there, but it's not glaring in our face where it's like a big floodlight on the side of your garage. Generally, the rule of thumb is I'd like to make sure if I'm doing a downlight situation, I want to be at least 10 to 15 feet in the air. Anything lower, you kind of get that spotlight on the ground. So I want to be a little bit higher in the air, and depending on what you're using for, you can use a different length of shrouds. The other rule of thumb is if I'm doing downlights in a tree, you still need to do uplights. And again, I like to do, if I'm doing 3 downlights, then I need 3 uplights. So this picture here, if I did not have these uplights in this tree, a lot of this bark, a lot of especially this foliage would not be lit. We would only have lighting here on the ground. So again, it's a rule of thumb. It can be broken, but if you're doing 3 downlights, make sure you have 3 uplights to go with it. And then area and path lighting. Generally, I know I've said it. I know several of you have heard it. Don't do path lighting unless you absolutely have to. And people kind of say how it's the necessary evil, and it is. I think it can be overused. And really, the problem isn't the effect. As you can see, this is a very well done design. It's the fact that they become targets. They get hit by extension cords and garden hoses and line trimmers. So when you're doing path lights or area lights, you got to be strategic. So as you can see here, these are well placed. We've got a nice light along our pathway here, but I try and make sure I pull them off to at least 12 to 18 inches from the edge. That way, if someone's walking across this way with a roller bag or a cart, they cut the corner, they're not have a less chance of hitting that fixture and yanking it out of the ground or knocking it over. Or if you get a chance, somehow to protect it. So protect it with a boulder or some sort of plant material, so that way it's a little bit out of the way. I will say that I will do my hardest to prevent putting path lights in turf. They just, at that point, they don't last. They definitely get hit by line trimmers. They get knocked over by mowers. They never really look good. So if you're in a situation, you're doing a design that you've got an edge and you've got a lot of turf, find a way to protect it, whether you're going to put a little planter edge on that, or you're going to have some outcroppings of boulders or something. Again, I know that I can't draw a hard line, but do your best to protect them or keep them out of turf situations. And then step lighting. This is a great example of where everyone wants to jump to putting a light right into the face of the riser. But here's a wonderful picture that this is beautiful stone. The last thing I want to do is cut into that and put a fixture right there. Or is a contractor really going to want to cut into the stone and put a fixture right there? So here's another example. You can see where we're protecting these fixtures. This is also an example where if you're going to light it, again, budgets being what they are, but I think we're missing one more in this area. We got a little bit of a dark spot. So make sure that, you're throwing even light on steps, and look beyond just trying to put those lights in there to where maybe if you have a wall. Again, this is beautiful stone that we're not putting any lights in here, but we've got the steps lit pretty well. So here's some examples where you can do an undercap light. you can put this light here is actually a surface mount, so you can see the little eyelets there, so you're not having to ask your contractor to drill through the stone. You can put the surface mount and a tiny hole for the wire, or run it up underneath the cap. And there are fixtures out there that do get mounted if there is that opportunity to mount them in there. So a lot of times, again, when we're looking at a two-dimensional plan, we get so focused on getting step lights, but look beyond that to see if there's any opportunities outside the steps to still illuminate the section. But again, there are times where you do need that. So here's a great example of being able to use step lights that are intended to be on the risers, and gives you that good look. And then here's a good picture of what that looks like from above. So on this project, the designer decided to do every other step as it goes up. So not every step is lit, and I'll go back and kind of show you how it's every other step. So it's still clear, safe. We don't have to worry about someone tripping. And then again, that's how it would look from the top looking down. And then Graze lighting, I do want to touch a little bit about hitting buildings. If there is that opportunity to light the building, I want to get the lights as close to the wall as I can. And I do that for two reasons. One, as you can see here, this is a nice brick home. If I were to pull these lights back, that texture would almost disappear. It would be a very, very smooth looking facade, and it takes away from its character. Also, I lose the control of where I'm putting that light. So you can see how, being up close, I can control the light around the windows, and I'm not shining light inside that home where I'm creating that glare. So it also gives me a lot more control. And same thing, these are the types of fixtures that you can use to get this effect here. And then again, not to be too heavy-handed with this, but this is one of my favorite pictures to show designers, because here we can take a nice plain white stucco wall, and if you're putting it up against the wall, it brings out some of the character in that stucco. And then now, rather than trying to light this up, I'm backlighting these, giving them that more intimate kind of romantic feel as I'm walking up to the front of the house, rather than spotlighting and getting light inside the windows. So we get a lot of questions, I've gotten questions about color. There is a lot of options out there when it comes to color changing. And I don't really have much to say in regards to the RGB, the red, green, blue. It's really kind of a fielder's choice of how you want to do it. I'm here to tell you that I would not use color to try and enhance a feature. So out here, there are people that are saying, hey, I'm putting green light on a cactus, and doesn't it look great? And it looks good, but I would much rather work in the Kelvin temperature range. And so basically now we have a plethora of options out there from lots of manufacturers to be able to select the Kelvin temperature. Now, the Kelvin temperature, or CCT, the lower the number, the warmer the light. So right now, I would say for us at Unique Lighting Systems, 2700 is probably our most popular color sold, and then 3000 would be second to that. I have a couple of theories why I think people are going that direction. I'll tell you one theory is that I think people go 2700 is because we were all conditioned that was the color of landscape lighting. Back in the halogen days, those bulbs only lasted 4,000 hours. And so to extend the life of them, people were putting less volts to them, putting them more closer to 10, 11 volts to try and extend the life out of them. And when you put less volts to a halogen lamp, you get that real warm look, 2500 look. And so we got used to that. Now with LEDs, they're running 40,000, 50,000 hours. We don't need to have that look as we go through. And as I'm doing more and more of this and more learning, I'm pushing my designers to get into the 3000s up into the 4000 range, because that brings out the greens out the blues. And here's an example of how that works. So the picture on the right is 2700, and the picture on the left is closer to about 4500. We didn't do anything to the house. This isn't funny picture taken time. This is just tuning the color to match. And as you can see on the right, the whites are very dingy, almost yellow, to where on the left the blues are the whites are popping, the blues are really being brought through. And so for me, if someone wanted to really bring the color out of a cactus, I would recommend that they would do probably a 4000 Kelvin, maybe a little bit higher, to bring out that greens of that saguaro cactus, so that way it looks gives it that real green pop, compared to doing a green lens on that cactus. Now, I'm not trying to say there's anything bad about color. I've got color changing bulbs here at my house, and boy, I had the best looking house on the street at Christmas time. So there is a place for them. But if you're trying to really bring out the crispness of your design, I would start looking at CCT over RGB. And finally, here's just a couple of resources for you to go to. The National Electric Code is administered by the Fire Protection Agency, so yeah, it's kind of in their deal. Again, I don't think you need to run out and go buy one of the books. You may want to go see if you can borrow one from the library and thumb through it, but it is out there. Darksky.org is a pretty good universal dark sky, and they try to be the organization out there to help people, HOAs, cities who want to create a dark sky ordinance. So they've kind of put themselves in a position to be consultants, if you will. So there's some good information off their website. And then the ILI, Institute of Landscape Lighting, is also a good place. They're an organization. They have a lot of trainings, a lot of classes, and I'm trying to get more and more involved with that group. And then, of course, we have some tips and tricks at uniquelighting.com. So. Damien, that's the presentation as I have it, if we want to go through more questions.
Yeah, we have a few to get through, and really just a few minutes to do so, so I'll try and be quick. More from Jeffrey. As a landscape architect and designer, night lighting looks best with pools of light, quote unquote. However, many municipal ordinances call for uniform lighting on especially commercial projects. Is there a way to get around that?
Not to my knowledge. Yeah, I agree with you. And it's they're trying to create a safety, so it's really tough to fight anyone when they're trying to do something for safety. So I wish I had an answer for you, Jeffrey, but no, there's really no way to get around it. Though the one thing that I do is kind of go back and saying, well, what I'm doing is more of the landscape lighting, kind of the accent lighting, and let the electrical engineer make sure he gets his foot candles on the pathways. Sometimes I've been able to do that. I've run into that with a lot of the hotels I've worked with. They got to have a certain level of light around the pool deck, and then I say, well, that let the electrical guy figure that out on the pool deck. Let me do my design in the landscape. So that might be a way to try and talk to them about that. But other than that, I don't really have much.
Okay. From an anonymous attendee, as they are listed, how does one decide what level of wattage / lumen production is needed in a path or step lighting situation?
Great question. You're really almost limited to the wattage of the fixture. So for us, and that's who I know, so our path lights have a maximum of 2 watts, and that's what I recommend. 2 watt LED. That's what I recommend. I wouldn't go lower than that unless it's super dark and it's out there, but the 2-watt LEDs are the best way to go for those. If you're using some of the bigger step lights, again, some of them take 2 bulbs. So again, 2 watts is your best way to go with that. If you've got one that'll take an MR16, which we do have one, I wouldn't go above a 4-watt in that range.
Okay. I've got a question from Ellum about water features lighting, and is there a code that exists for that?
There is, and it's changing. So I'm not exactly 100% up to date, but you do need to have a transformer that's rated for water. That may have changed. I know they're going through that, but and you need to be a certain amount of feet. I want to say 50 feet away with your transformer to the water. But other than that, they need to be water, rated fixtures that go in there. I'm not as well versed on that. I apologize, but there are a few things that are out there.
Great. So we do have a couple of other questions still coming, but we have hit our time limit for today. So what I'm going to do is send those directly over to Brian. Do you have a contact slide, Brian?
You know what? I forgot to put one in there. If everyone's,
That's all right.
If everyone's ready, I can give it to him right now. It's Brian, BRIAN .QUALLS @uniquelighting.com. Or if you go to Unique Lighting, you can see my contact info there.
Yeah, so we'll get these questions sent over. I'll get those sent over to Brian post webinar, and he will, as he's mentioned, happily have further discussions with anyone who gets in contact with him as well. But yeah, if you do have more questions, shoot them over to him or through me. I'll get them sent over. We are posting this webinar, of course, up on the website later today. So if you need to rewatch a section that you were unsure about or missed, or want to pass it on to anyone who couldn't make it today, just look out for that recording getting posted up later this afternoon. Just in finishing up, I want to say thank you again to Brian for his time in presenting today. I know it's been a busy scheduling for January, but yeah, it's been great to have him on board, and he has done a couple of presentations with us in 2018. So if you want to listen to those, it goes a little more into the sort of design and engineering philosophies of landscape lighting. You can find those on landeffects.com and use the guest speaker filter to find those again in 2018. But yes, thank you again, Brian, and thanks for everyone for attending today and all of your fantastic questions. Have a great weekend.
Thank you.